Hey everyone, in today's video we're looking at probability rules. I mean, we know probability rules, but like applying probability rules to find probabilities. So essentially, instead of having to rely on simulations or like these long run relative frequencies, we can find probabilities using different methods, things that we know to be true. And let's just get right into talking about those. So before we begin, I want to make sure we have a very clear understanding of what an outcome is. You'll hear this word a lot as we study probability. So an outcome is a single result, of some random process. So again, that could be like flipping a coin, rolling a die, performing a computer simulation. Those will all produce an outcome. An outcome is just one result, single result. It can't be broken down any further. So when we flip a coin, the outcomes are either heads or tails. You flip a die, you have 6 different outcomes altogether. You can roll a 1, 2, 3, 4, 5, or 6. So outcomes lead into this next term that you're going to hear a lot. It is called an event. So an event in probability is a well-defined set of outcomes. So essentially, several outcomes in one. Give me an example for this one. An example could be we roll a 6-sided die. Roll a 6-sided die. An event, we could define an event as, we'll call it event X, rolling a 1, 3, or 5. So these 3 separate outcomes are all lumped together into this one event. So again, an event is essentially a collection of outcomes. That's really it. And then what we're really doing today is, again, not looking at probability as a long run relative frequency. We're looking at the classical definition of probability. Classical, or maybe sometimes known as the theoretical definition of probability. Theoretical probability. This is going to allow us to answer questions without having to perform simulations or countless amounts of trials or something. And this is really kind of an expression, an equation. It is the number of we should really say equally, the number of equally likely successes divided by the number of equally likely outcomes. This is actually a incredibly important concept and something that was developed, I believe, in the 1500s. There's this very, very troubled man named Girolamo Cardano, an Italian born in the 1500s he aspired to be a doctor. His father said, no, you're not going to be a doctor, you can be a lawyer. So whenever old Cardano there tried to go to medical school, father wouldn't pay for it. So Cardano financed his medical degree by gambling. And it really all comes down to this right here. Suppose I flip 2 coins. If I flip 2 coins, let's find the probability of getting heads and then getting tails. What's the probability? If I flip 2 coins, I get 1 coin to land on heads and the other coin to land on tails. So this was a long time ago, 500 something years, right? The intuition would have been, okay, so I'm either going to get one coin that's heads, one that's tails. I'm going to get both coins to land tails face up, or I'll get both coins to land heads up. So since there are three different possibilities, someone might have thought that, well, hey, the probability of getting one heads, one tails is 33%. That happens one time out of three, but that's not actually true. And what Cardano created and how he was able to make an absolute fortune on gambling to finance his medical degree was create this thing called the sample space. Very powerful, cool concept. So the sample space, it lists all possible outcomes. Again, the sample space lists all possible outcomes. So if I flip two coins, let's create the sample space. We'll just draw a little rectangle here to represent all possible outcomes. Put like an old S down there for sample space. So the possible outcomes, if I flip two coins, we've got most of them here. Certainly I can go heads, heads. Or I could also get the first coin to land heads, the second coin to land tails. I could get tails, tails. Or I could also get tails, heads. One coin, the first coin lands tails, the second coin lands heads. So when we look at this sample space, there's not actually only three outcomes. There are four altogether. So the probability when you flip two coins, getting one to land heads and the other to land tails, the probability of getting one heads, one tails, well, if we count the number of equally likely successes, the successes in this case are where I have one coin head, one coin tails. That happens here and also here. So it happens, number of equally likely successes happens two times out of the total number of equally likely outcomes. The total number here is 4. So you actually have a 50% chance, not a 33% chance. Again, very important, very important concept there. This is immensely powerful tool for finding probabilities. Now, I'll just give you a couple more definitions to wrap up this video, things to keep a lookout for. We are going to need to know what disjoint means. Disjoint. Another word for that is mutually exclusive. You'll see both of these terms used interchangeably as we work through the course. Disjoint or mutually exclusive events. These refer to events that are impossible to occur together. So what I mean by this is if I flip one coin, only one coin, if I flip one coin and that coin lands on heads, I can't get tails as well. When I flip this coin, I'm either going to land on heads. If it lands on heads, that means tails did not happen. That is exactly what this means. I can't flip one coin and have it land on heads and tails. Alternatively, there's another thing called independent events. An independent event is an event that does not rely on an event that does not rely on previous outcomes. So this is where if I flip the one coin again, I have an equally likely chance at getting heads and tails. I flip the coin again. Once again, there's a 50% probability that I land on heads or I land on tails. If I flip the coin again, it doesn't matter what came before it. I still have a 50% chance of landing on heads or tails. We'll talk about dependent and conditional events later on in the week. That should do it for now, though. Again, this is the most important thing to take away from this video: the classical definition of probability and how it comes from this thing, the sample space. Once again, thanks for watching, guys. I'll see you all in class. Bye-bye.